A/B testing is wonderful, and it's something that's close to my heart. A/B testing can't make a bad game good, but it can certainly make a good game better. And it's an interesting sort of mix, because whilst data science can say whether it's A or B, I still think we need game design to say as whether it should be A or B that decides we pass on to the data science team. And also, if we try A and B gives a lift, how do we decide whether B is statistically significant based on those sort of tests? So I hope Steve will explain some of these things for us in today's presentation. I'm giving away little trivia prizes. Steve's been in the industry for years, and he's famous for writing some well-known Commodore 64 games. If you may have played some of his games. So, what year was the Commodore 64 first produced? Can anybody tell me? I'll say higher or lower. It's in the 1980s? 82. Who said 82? There we go. 82. Steve, it's all yours.
Thanks, Nick. Hope I don't disappoint. I'm not so sure that they're very well known, those Commodore 64 games. Don't go looking for them, please. Okay, thanks for the intro. I'm just going to talk briefly today on A/B testing, specifically for mobile applications and games. There are particular challenges presented when you're looking to do A/B testing or split testing on mobile devices. It's something that's been used very successfully in the online space for years, probably championed initially by folks like Amazon, then Google, Microsoft, and now everyone, routinely has A/B testing and data-driven development at the core of their design processes. I think we're seeing it slowly becoming more adopted in the mobile space because of some of the tech challenges and also maybe some of the, I suppose, just the cultural and experience challenges. People just aren't used to thinking this way. So I'm going to bring you through 10 different tips involved with A/B testing, hopefully to give you a sense for some of the things that work well, some of the things that don't work so well, just delivering some of the experiences that we've generated working with lots of different customers delivering A/B testing solutions. So this sort of one line underpins a lot of what Swerve is about, and it's really a lot of what A/B testing and data-driven cultures are all about. I don't know if you're familiar with Admiral Hopper. She's an absolutely fantastic lady. Unfortunately, she's passed away, but she coined the term debugging, and she also was responsible for the COBOL language. Some of us might not thank her for that. But she also designed the very first computer compiler. So an absolutely amazing lady, but in her talks and when she's presenting, she was a big proponent of data-driven decision-making, actually using real data to verify and back up some of our opinions and some of our thoughts about what is the right thing to do. So that's going to underpin a lot of what I'm going to talk about today. But just a quick refresher. Hands up anybody who's run an A/B test. That's pretty good, actually. It's usually depressingly zero in most presentations I give, so great. I just want to give you a very brief overview of what an A/B test is. And A/B testing is just one small slice of the types of different testing activities you can do in your games or in your applications. Really, we should be talking about split testing or multivariate testing or even just optimization. And I'll get onto some of those differences later. So A/B testing very simply involves splitting your population into groups, presenting different variations of your game to those different groups of the population, measuring their response according to some value that you care about, probably revenue, perhaps conversion, perhaps something a little more abstracted from the true KPI you're interested in. As a result of looking at the results coming back in from your users as they're consuming these different variations, you choose a winner based on whatever criteria you want to use, and then lock in that result and make sure that everyone from that point forward gets that winning variation. And what you do is, by degrees, you're evolving the game service or the application forward in time in little mini steps. And at each point in time, the decision you're making is guided by real data and an underpinning sort of science or statistics that tells you the actions you're taking are valid. So, in thinking about A/B testing and in trying to instill, let's say, a data-driven culture or an A/B testing culture inside your organization, there are a couple of things that we'd recommend. The very first thing we'd recommend is don't try and boil the ocean right from day one. Start simple. Look at low-hanging fruit things to test and look at ways to get your organization to see the value of a test as early as possible. So don't create a huge framework right from day one. Figure out the simplest thing you want to do, implement that, and look at the data coming back, because you might be surprised. And actually, the magic happens in the surprise. You start running different tests, things that you think are crazy turn out to be the most valuable lessons learned. So starting simple. when we talk to customers initially, we try and figure out what are the things that you think are going to move the needle most in the shortest space of time in your game. And we try to relate that to some sort of revenue generating capacity. And typically they fall into a number of different categories. And here's a couple. So looking at if your game is heavily driven by ad monetization, looking at the timing and the display order of those ads, a real critical thing to test is the first point in time which you display the first interstitial. You want to give users a good experience in your game initially, not necessarily interrupting their flow, and then at some point later, if they're not going to be a monetizing user through in-app purchases, you might switch then to an ad network to try and monetize. So figuring out that delay is really crucial. Another one is, and a classic one that folks at Vuga have talked about quite frequently in the past, is the choice of guide character in your tutorial. So a lot of games have a tutorial flow. You're trying to guide people through the early stages of the game. And the choice of that guide character actually has an impact on the flow of users through your game. It's not a very intuitive result, but it's a fact. Other things are quick questions posed a lot of times when you're thinking about game design is, should we present a user with an option to log into the game right at the start, or should we sort of give them a reason to log in or register at some point later in the game? And they're sort of very difficult decisions to make, and they're as much about psychology as they are about monetization. So, a good way to go about this is to try different strategies with different groups of users and just see which works based on your particular game and your particular sets of users. So the very first thing you're going to want to do to create an A/B test is make an application that is capable of delivering different variations. And the simplest thing to do is just bake those variations into the app itself. Now, this isn't necessarily the way you want to go in the longer term, but just to get to that early win, that's the way to do it. So let's say we're trying to test these two guide characters, bake the two characters into the app, and then create a very simple sort of client-server interaction. So as a session starts on your application on the left-hand side, as a user starts playing the game, ping the server. The server resolves that user ID and decides that user is in variant A or variant B of my A/B test, and fires back a message to the device and says that user should be in variant A. And then the game itself can switch on that and display the appropriate guide character. Very, very simple stuff. Not very great from a perspective of a process and looking at scaling this up, but this is just to get to that earliest win. And then the device itself, as the user plays the game and hopefully makes their way through a tutorial, sends events back to the server, and then you use whatever metric system you're using to count those events and say which one was the most successful, how many users actually completed the tutorial. And that's it. That's about as much as you need to run the very simplest form of test. And that's what we'd recommend you do initially. Don't go crazy building frameworks. Figure out, does this sort of thing work for your organization? And more importantly, can your organization consume the result of the test in a sort of a cultural way? So building a data-driven culture is central to all of this. Design is not something you can throw away, clearly, but validating designs and making decisions based on real data and based on exactly how our users are playing the game is really what it's all about. So it's not about having lots and lots of graphs. It's really about figuring out how can we put data up at the same level as our experience. So you want to avoid the hippo. The hippo is the highest paid person's opinion in your organization, and we all have a tendency to put a lot of momentum and a lot of stock against the people with most experience, the CEOs, the lead designers. Now, testing doesn't get rid of the need for a CEO to make a decision or get rid of a lead designer to come up with a great idea, but what it does give you is a sort of a democratic way to judge the decisions that are being made. So you still need great people to come up with great ideas, innovate, and come up with suggestions of things that might work inside your game, but then try them out and test the results and look at the real data coming back in to assess which is the best. And a real important point for building a data-driven culture is linking everything you do from a testing perspective right the way through to a KPI that your organization is going to care about. If the CFO in your organization doesn't care about the testing, it's very likely that that testing system is just going to bounce straight off the organization, and you'll never instill a testing culture. So when you're running tests, make sure you know what we're trying to do here is move a needle on revenue, ideally, or move a needle on some second-order effect that is directly correlating to revenue in the game. So, in the case of an interstitial timing, it's linked to the click-through rate for the interstitial, which links directly through to the revenue from your sort of other non-monetizing users. You're going to start running lots of tests. You'll have lots of ideas, hopefully, lots of creative suggestions coming in. And now you start getting much more concerned about the speed at which you can run these tests. So in a data-driven organization, this is a sort of closed loop you want to have. You want to have measurements, metrics coming in from the game, looking at what your users are doing. You want to test different hypotheses against those users, test different design ideas, test different layouts, test different UIs. And then you need to be able to take very rapid action based on what you're seeing coming back from the data. And that presents challenges for an organization, both technological and sort of cultural challenges. And you really want to avoid this sort of situation. So I'm sort of nearly naysaying what I said in the first sort of keep it simple slide. You don't want to be building tests into code. You don't want to have to push out a new version of your application through the App Store, going through certification process and approval all over again and going through expensive QA just to put another test out live. Also, just managing tests in this way is just not the way to go. And anybody who's written tests through code knows this is non-scalable. So what you really want to do is do what anybody who's taken a CS degree knows is important. You want to separate your code from your data. In design, you do this all the time. You have a level editor separated from the code, which is actually running the game itself. So you can make very quick changes in the level editor, and no one has to go talking to an engineer to make changes in the underlying code. Same is true for testing. You want to separate out the things that represent the game, iterating forward the game in different releases. The things you want to test, you want to elevate to a data layer that you can then curate and manage in a content management system. So there's also different frequencies. If you look at, say, the product manager responsible for testing and optimizing the game, they're working at a fairly high frequency. They're trying out lots of different things at different points in the game. And quite often, as your teams scale up, you'll have multiple product managers or analysts or testers who are responsible for different phases of the game's life cycle. So all of these things need to be able to continue uninterrupted, while at the same time you've another sort of lower frequency tick that's happening where you're pushing out new app updates. And in fact, it's a lot of the decisions that are the realizations you get on that sort of top data-driven high frequency layer that push down into the next iterations of your application and motivate the changes you're going to want to bake into the game in the longer term. To do that, you need to have the separation layer, which is your test framework. Now, I can talk in great detail about that, but come talk to me afterwards and I can explain more about what you need there. So you might be concerned then about QA. You've got sort of product managers changing the game. That obviously raises very large red warning lights and flags in most organizations. So what you need to do is embrace the idea of failure, but being able to fail very rapidly. And there are ways to mitigate the problems that arise as a result of that. One is having a kill switch, an ability to turn off a test very rapidly. Another way to do it is to have a QA process that allows you to stage tests. So roll tests out, but only have those tests apply to QA users. Identify your QA users with a device ID or a user ID or something like that. And only when you've run that through that QA process do you actually hit the go live for the full test rolling against your full audience. Or another strategy is to use a ramp-up strategy. When you roll a test out, roll it out only to a small percentage of your population, say 5%. Check everything looks fine, and then once you're happy that nothing pathological has happened, ramp up the test to your full 100% audience, and then start looking at the data coming in. Another thing you're going to want to do is, as you're starting to run lots of tests, there's a tendency to try and group tests together and change lots of things at the same time. That's usually a bad idea. What you want to do is minimize variation in any given test. Now, there are lots of strategies for dealing with this, multivariate testing, multi-factor testing, but when you're doing the simplest A/B test, you want to keep it really simple. Here's an example of a test in the online space that I think is a good illustration of this. We had two variations, A and B, and the idea is we want to see the one which gives us the greatest conversion rate, the greatest number of people who signed up for this email newsletter. Now, if you look carefully at the two messages, you can see actually two things changed. First off, the call to action changed on the right-hand side. It's free, has been indicated. But on the left-hand side, they introduced social proof. They indicated the number of other people who reacted or joined the email list. Now, common knowledge is social proof should increase conversion rates. But in this case, it was actually the B variation that won by a large margin, simply because it was probably the call to action that was most effective at changing people's behavior. So what you really want to do in this situation is create 4 different variations, looking at each possible combination of a change in call to action and a change in the social proof annotation. When running tests as well, you have to be very careful because testing, you're quite often looking at a very specific result that you want to check. It might be a conversion rate, a click-through rate, number of people who completed a tutorial, number of people who purchased an item. But sometimes you have to stand back as well and look at, well, did that actual test conversion have a longitudinal impact, an impact on the sort of longer term view of my game statistics? So here's an example. This is a test. Let's say a couple of variations, and fairly quickly into the test we discovered that one of these variations is doing really well by whatever metric you're using, and I'll mention some metrics in a second. But then when you step back and actually look at the data for the game, you realize something really pathologically wrong is happening to my users. While this is sort of revenue curves over a period of time. And we've sort of got an expected revenue curve. It's a game that's trailing downwards. but 2 of our test variants are generating users where the revenue per user is substantially lower than the other 2 variations. Something has gone wrong here in 2 of the variations. And one of those variations might well be the winning one. So you have to be very careful to step back sometimes and look at your overall data and take a longitudinal view. This means you need to be able to look at the data coming into your game by test variation. You need to be able to segment it by the bucket or the test that user was in, so you can correlate a test with the actual results you're seeing. You also need to be careful about temporal effects. This is one that catches a lot of people out. So let's say you have an average revenue per user per day, something like that you're interested, or let's say average number of sessions per day, something like that. Some of these KPIs have a tendency to have temporal impacts. So anytime you're looking at your data, you'll see a peak during the day and a trough during the night. And then as you release in, say, multiple regions, you start to see this flatten out as you get multiple peaks and troughs. You can sometimes be confused by a result. You see if you start a test at the start of that peak and you start seeing your data trough downwards, you might confuse that with a badly performing test if you're comparing that against just a daily average. So just make sure you understand the data you're looking at and assess it in the proper light. This is also one that surprises people, testing new users versus repeat users. Sometimes the things you're going to want to test relate to UI and experience. So let's say it's an interstitial ad layout like this, and you're just changing subtly the locations of your call to action buttons, the cancel button and the OK button or whatever. Existing users will have learnt a pattern of behavior. They'll have learnt your UI. Even if your UI isn't so great, they'll have learnt which button works where. And quite often when presented with something like this, or even just an in-game menu item or whatever, they will instinctively click to where they expected the button to be, or point at or whatever. If you introduce a variation in the UI, those users who learnt the old behavior might be confused. They might be distracted. They might be annoyed. And that sort of confounds the data you're seeing about the new users who are coming into your game. So you're not really getting a good sense whether this is a positive or negative result. So you need to be able to separate your users, test groups of different users in different ways. This primacy effect means you need to be able to run a test only against new users or against users who have a particular version of your app or whatever. So you need that capability in your testing framework as well. A classic question that comes up nearly as the first or second question about testing is, how do I test prices and not annoy the user base? How can I sort of give one user a price point A and another user price point B for the same thing in my game? Won't those 2 users start talking together and maybe interacting on forums and maybe causing negative backlash? And that certainly has happened historically. There's some good sort of cases in Amazon where they discussed pricing DVDs and the impact that had on the user backlash. In practice, this doesn't happen very often, and in fact, it usually is a very small single-digit percentage impact on the testing and your user base. If you are really concerned about this, there are a number of ways to mitigate it. The most simple way is don't test prices directly, test offers, test discounts. And people rarely complain about, well, user A got a discount of 40% and user B got a discount of 25%. There's an expectation that discounts somehow are due to my particular category of user or a timing thing or whatever. So this is a way to sort of hide a pricing change in an elasticity test behind a sort of a temporal offer. When you're testing prices, another sort of question that comes up quite frequently is, how can I test prices? I can't just dynamically change the price of an item in the App Store. You have to pre-declare in App Stores the SKUs or the items that have hard currency-backed payments associated with them. Well, the way to do that is 2 things. First off, set up a whole series of different SKUs at all the different price points you might want to test. And that means maybe you're creating 20 or 30 SKUs. Here I'm only showing 5, but typically you'd have quite a few more of those covering every possible price point you think might be relevant for your users. The second thing is call them gem packs or soft currency packs or something like that. You don't have to describe the amount of virtual currency you're going to give to a user in this instance. And then at runtime during the game, you can, your product managers can now start playing with different relationships between price and value. They can say $4.99 gets you, 100 coins, or it gets you 200 coins in a B variant of a test. You can also add in different descriptions at this point inside the game itself. So you're not sort of faking the price point. What you're doing is you're giving yourself an ability to try different price points at different points in the game. Second to last is run the math. Now this is an area, once you get into more sophisticated testing or multivariate testing or looking at data associated with tests, at some point you're going to start needing sort of stats guys, math guys, or quants on your team, simply because you're going to be dealing with ever-decreasing law of return. You're going to look at data that's noisy, you're going to try and discover is this data telling me something that's actionable, or is it just noise in my underlying sort of KPI? And that can be hard to analyze. Certainly if you're just looking at it from a non-statistical perspective, it's nearly impossible in some cases. So you need to run the math, you need to understand the statistics behind testing. And there's a number of different variations on testing statistics, from the frequentist view, null hypothesis testing, through to the more, the more current Bayesian testing and Bayesian inference. Fundamentally, there are two types of errors that your tests are going to give you. One is a false positive, a type 1 error. That means, you're looking at data and you see a KPI upswing and you think, yes, that's great. There are more people buying this item than I expected. That's a positive result. Let's lock that in. The problem is, because data is inherently noisy when you're dealing with user populations, there's always variance in people's behavior. You might just happen to see the result when it's high, and then the next day it's going to go low again. So you need to have some mechanism built in to decide, when can I start looking at this data and not be subject to early, false positives. Another area is the false negative, or the ability not to see a true result. So this is a situation where you actually have a result in your data, as in the population is performing better, but you still don't have enough information to tell you that it's better. So you don't have enough power in the test. So in that situation, you've got a false negative. So you need more data to figure out, or you need to run some statistical analysis to figure out which is the right situation. Here's an example we saw in real. I've got 1 minute left. We had a test that was running for a while using a Bayesian inference, and after about 10,000 observations, we saw one of the variants was the winning variant. But after a period of time, it settled out completely differently, and in fact, the opposite variant, the one that was performing very poorly, turned out to be the true winner. So you have to be very careful about that. And finally, save your results. You'd be amazed how much information is stored in test results historically. Save that, curate it, and use it when you're looking at future game designs. Okay, thanks very much for your time.
Thanks, Steve. We have a chance for a couple of questions. Any questions, Steve? Well, maybe I'll ask sort of one question. Typically, how many tests do companies run at the same time? With multivariate testing, it's easy to just isolate one test, but what happens when you have 3, 4, 5, 6 tests at the same time?
Yeah, typically you have multiple tests running at the same time, particularly for larger studios. So you need mechanisms to allow tests to run that don't interact with each other. So a great way to do that is to actually partition your population into population groups and then run tests separately against each group, so you guarantee there's no interaction effects. Or you actually run a multivariate test, which handles the fact that interactions happen and actually look in the data for those interactions and counters for those. So it depends on how you're set up.
Any more questions for Steve? Okay.